This is a typical structure of an atom, right? We have proton at the center, or the neutron at the center, and surrounding to that, what we have is the electrons moving in a particular path, right? Now, what happens when external energy hits a particular electron? So, as we know that that these electrons will move in a particular fashion, and it is having a particular designated path. It cannot stay randomly for the entire electron crowd, right? So whenever there is an external energy source or stimuli, we represent it using h nu, E equal to h nu, where h is the Planck's constant and nu is the frequency, which is again c by lambda. Then if the electron is in the lower energy state, there is a chance that, or if you provide the energy which is the difference between these two cells or the consecutive cell, what it will do is it will simply absorb the energy and it will go to the higher energy state. This particular phenomenon is called the absorption. Okay. Now the second option could be an electron moving in its outer cell, and what happens? This electron tries to come down to the lower energy state. So in this particular process, what happens? This energy difference, it will release as a photon. It is called spontaneous emission. So absorption is here, spontaneous emission is here. Now there is a third possibility which is called stimulated emission. What it says that normally, we assume that whenever there will be an external stimuli, it will hit the lower energy state and it will move to the higher energy state. So the absorption dominates, because in nature, electron tries to be in the lower energy state because that is the most stable state. Okay. So the number of electrons in the lower energy state is relatively higher than the number of electrons in the higher energy state. And that is the reason the absorption always dominates. But that doesn't mean that there can't be any other option. The second option is this h nu energy can hit a higher energy state electron, and it can decouple this electron from higher energy state to the lower energy state. And in this particular process, it emits one h nu, and since we have already another h nu, so from h nu we get 2h nu. It is called stimulated emission. But if you notice carefully, if you want to ensure this particular process to be dominated, you need to ensure that this h nu hits, or the probability of hitting this particular h nu in the higher electron region should be more. That means you should have some condition which is known as population inversion. So the population inversion is a condition where by some means, there are different means of doing that, we ensure that there are more number of electrons in the higher energy state than the ground level. And that is the very basic of the laser system. If this particular criteria is not satisfied, you will not get the lasing action. So that is a brief about the stimulated emission and the population inversion. If you can satisfy this particular condition, then your lasing action will take place, and that is the reason in normal condition we do not get any lasing action. Under a particular scenario only we will get the lasing action. Okay. Now, why this particular, or why laser beam is so popular in manufacturing application? Why not the ordinary light beam or the light sources? There are certain properties which makes this laser beam very special when you compare to the ordinary beam, and this is very important to understand to any applications of the lasers, whether it's a cutting application, welding application, surface modification application, because if we do not understand that what are the properties that are unique to the lasers, there is no point of using laser as a tool for cutting. There can be other options like wire cut EDM, you can have abrasive water jet cutting, but why laser? And once you understand the unique properties, then only you will know that whether to use laser as a cutting tool, because when you talk about the laser cutting, it comes with a cost, because it will involve several thousands of rupees per hour if I sum it up. But if you do not need that much amount of precision, then obviously I will not use the laser. And that is the right way of selection, the proper cutting. I will simply go for, say, turning operations or iridium or any other type of operation. So the first unique property is the coherence. That means laser is basically a combination, it has a dual characteristics, like characteristics of wavelength as well as a particle nature, right? So by coherence we mean that it will be having same phase, okay? Also, the second property is the monochromaticity. That means this will have almost like a single wavelength. If I say 1064 nanometer laser beam, practically it will be 1064 plus minus 10 nanometer or so. This is again very important, because when you are talking about any material processing, again whether it's a cutting, welding, how much laser will get absorbed in that particular material, that depends on the wavelength of that particular source. Because if you see the literature, it will say that there is a curve between wavelength versus absorptivity. Okay? Based on that only we select what laser to select, because there are different types of lasers. We have fiber laser, we have CO2 laser, we have excimer lasers, and depending upon how these lasers or lasing action takes place, or how the constructions are made for this particular lasers, you will be having different wavelengths. And depending on your requirement, whether you want to cut the metal, whether you want to cut the wood, whether you want to cut the perspex sheet, you will select a particular type of laser. It's not like I will always select the fiber laser. No, it's absolutely no. Fine, if you see this particular figure, then this shows that if I switch on the laser in continuous wave mode, then there are see the cut quality. So this is basically drilling, this is not cutting. And if you operate the laser in pulse mode, you get very good quality. So the idea is not, if you have a laser and you just switch it on. Okay, you should understand that what is the material processing regime, or what is the time domain that you want to work on, and select the laser power and the pulse duration accordingly. So it's not always good to have very high power lasers. So you should understand the application, and then you should understand what is the time domain you want to work on. So that is very important. So there are different types of industrial applications for the lasers, laser cutting, drilling. So drilling is a little variant of cutting on, because you just switch it on, switch it off. So there are many applications in cutting the diamonds, especially in the Gujarat area. So we have, or the first industrial application was demonstrated using the laser drilling operation. Okay. So cutting, drilling, or PCB board, if you want to cut the PCB board for electrical circuit making, you can do that. Stain cutting for medical application, if you want to have medical devices, if you want to make small medical devices or small stains, you can use femtosecond laser to cut. So there are many applications. So as I mentioned that if I talk about lasers in manufacturing, almost 75% of the industrial applications are dominated by the laser cutting operation. So if you see any labs who are having this kind of, or any industries, mostly they use lasers for the cutting applications, and some of them use it for the welding application. There are specialized applications like shock peening and then the stain cutting, but those applications are little limited. So if I give you an overview how the laser cutting head looks like, because that is something is also very important to understand, otherwise it will be like a black box kind of things, that how the process works. So if you have a laser beam, what you need is focus index. Okay, this is important because, as I mentioned, that the power density or the energy density, that is very important. It's not the nominal power. To give you an example, if you buy a laser system for your institute, say if you are buying say 2 kilowatt laser or 3 kilowatt laser, okay, that is called the nominal power. That means the maximum power that it can have. Okay, but the main thing that matters is how precisely you can focus the laser. That depends on the quality of the laser beam. So there are different quality factors. I'm not going into the details of that because we are mainly focusing here the application part. But just remember that it depends on many factors. How the intensity of that particular laser beam is there, and what is the quality factor, whether you can focus it down to a narrow region or so, because that is something that will limit the feature size of the cutting tool. And based on that only, your what is called the cost of the system will also vary. So what we have is laser beam, and then we have something called the focusing lens. It's normal plano-convex lens, but these lenses are not the ordinary lenses. They should sustain the laser beam on the damage threshold. So this focusing lens are a little costly. And then what you do is you select the appropriate lens based on this particular distance, because the lens can have different focal length. By making this arrangement, what you are ensuring is that you can focus the parallel laser beam to a small spot diameter, right? And then you can mount the entire head into a CNC. So you can move it up and down depending on that, you can focus. Once you ensure that, what you are ensuring is that on a surface of the workpiece which you want to cut, the required energy density or the power density is made. Okay? So the melting is ensured. Okay? Depending on the power, depending on the time, you can also vaporize the material. Once the material is melted or vaporized, depending on the application, the next step is to blow away the molten material from that particular path so that you get a cut. And that is the reason we need something called the pressurized gas. So this pressurized gas can be oxygen, it can be nitrogen, it can be other things. But if you are using oxygen, you have an additional benefit. It's called oxygen assisted laser cutting. What it does is, oxygen causes exothermic reaction, and by that particular process, what happens that you have less, or you have the required energy density will be relatively less. So if you are not using oxygen, if you are using nitrogen, you can also perform the laser cutting, but your energy requirement will be relatively high. But oxygen is relatively cheap, so why do you use nitrogen? You use the oxygen, take the advantage, because here we are not bothered about the oxidation of the material. Here we want to ensure that the curve width is minimum, that is the cut width, and how best we can utilize the laser to melt the material and blow it away. So the mechanism of material removal in case of laser is melting and or vaporization, and then you use a coaxial gas jet to eject out the molten or the vaporized material. So that is the basic fundamentals of the fundamental principle behind the laser cutting process. There can be different types of lasers which are used for the laser cutting application. It started with CO2 laser because CO2 laser is something which was which dominated the industrial market or industry for a very long time before the fiber laser came into the picture. But it has some limitations. It has a high maintenance cost, and that is the reason nowadays the fiber lasers are relatively popular. But these fiber lasers are in the market for last few decades only. But predominantly it was CO2 laser which was used. But if you see the wavelength, it's 10.6, which is more than 10 times of the fiber laser. Now, as I mentioned that this wavelength has a large dependence on the absorptivity of the material, we have a better solution to cut the fiber lasers, to cut the metals. So for most of the metals, it has been observed that 1064 nanometer or 1.06 micron wavelength gives you good absorptivity, and that is the reason we use fiber laser for cutting purpose. If you want to cut, say, stain, or if you want to cut, or if you want to have pulse laser, then we use something called ND YAG laser, which is a pulse laser, not a continuous mode laser, but you can run it in a continuous mode also. And if you want to cut the polymer or the perspex sheet, then you can use the CO laser. Because if you use the fiber laser there, it will not get absorbed because 1.06 is transparent to the polymers. So that is the reason you have. So you have a less coupling efficiency. So that is the reason you use the CO laser. The power range is something like 500 to 5 kilowatt, but depending on the application, you can have your customized laser system, which can be in the upward. It can be 20 kilowatt, 30 kilowatt as well. But those are having very precise application. It's not a commonly used one. Focus spot, normally we keep it something like 100 micron to 300 micron. So it's a focus spot diameter. Okay. So if you are focusing the beam of 100 micron, then after melting it will be little more than that, because once the laser interacts with the material will spread a little bit. So maybe if you are using 300 micron spot size, you will get 500 micron width. So it depends on the absorptivity, how much the lasers are being absorbed. This is again important to know because you should understand the requirement. For example, if you have a requirement of say 200 cut will be always maintained for your application, which can be very precise, then obviously you cannot afford to have 300 micron spot diameter itself, because then once it cut, it will be always more than 300, right? So you should understand the requirement, and accordingly you can select the particular lengths and particular laser source which can give you spot diameter less than the curve. So that is the selection criteria. So there can be different methods of laser cutting. So for most of the metallic application or metal cutting, we use the principle of melt and blow. That means it will create plasma once it interacts with the material, and then you use the gas jet to blow away the molten material. So that is the predominantly used mechanism for cutting most of the metallic specimen. If you want to cut specific materials, for example MS or mild steel or SS, you can use oxygen as an assist gas, and in that particular process you can save up to 70% of the energy. Okay, so if you have a 2 kilowatt laser, if you use the this oxygen, then maybe without oxygen you can cut 1 mm. With oxygen you can cut up to 4 mm thickness. So this oxygen will give you additional amount of energy, so that you can have better penetration and you can cut much thicker plate than without the oxygen. There can be another mechanism for those materials, for example wood or the plastic, which we cannot melt. So what we can do is we can have very high peak power and vaporize the material. Okay, and then we use some kind of mechanism to blow away the vaporized material or that residue. So the third mechanism is vaporization, and that is predominantly used for cutting of wood and the plastic. Okay. It largely depends on the wavelength, also on the surface finish. So your surface finish is also very important. So next time if you say 200 watt or 300 watt, please ensure that you are talking about the absorbed power. It's not about the panel power. Panel power can be anything. But if your absorbed rate is 50%, so your absorbed power is not 500 watt, it's 250 watt only. Okay. So this is your energy input. Now, on the right hand side, we need to ensure that we have some term which is also giving us a unit of watt. Okay. Because eta is unitless, P is something in watt. So this is the absorbed power. So it's normally defined in SI unit as watt. Now, what it says that, okay, if V is the cutting speed and W is the cutting width and T is the thickness, for example, I took the example of 5 mm, so you select T as 5 mm with, V scan speed. So for unit time, you will say 5 meter per second for unit time, let us consider. Unit time will be carrying out the mass balance or energy balance equation, sorry, not the mass balance, energy balance equation. So this W into T into V, this particular term will give you the mass, because this particular formula resembles to mCp delta T, right? This is a simple mass energy balance equation. So WTV is the unit time, the mass that we are removing, because here we are interested in the removing of the material. If you can ensure that, then our job is done. So aim is there, and sorry, this is basically a volume, not and rho is the density. So mass equal to volume times density. So this is volume WTV unit per unit time, obviously, and rho is V. So m equal to d into V. So this is mass, and then this is Cp. Cp is the coefficient of thermal Cp is basically a specific heat at constant pressure. So this Cp value is also available in literature. Delta T is the difference between the temperature. So temperature means melting temperature, because here ultimately you need to melt, right? So melting temperature for steel, say around 1400 degrees Celsius. So 1400 degrees Celsius minus room temperature, which is almost equal to 1400 degrees Celsius. So delta T, you can put it as a melting temperature. Then here the initial starting material was solid, but at the end you are basically melting, and then so there is a term that should come into place which is called the latent heat of fusion. So for melting we are having latent heat of fusion, but at the same time we are just vaporizing, we are removing the material. So that is the reason we have something called the latent heat of vaporization as well. So this particular formula you can use not only for laser cutting, you can also use it for welding purpose, surface modification purpose. It's just like what are the terms that you are selecting. For welding purpose or surface modification purpose, you do not need to select the vaporization, because there only the phase change is involved up to a certain depth. So up to that you just consider the latent heat of melting. Okay. So this is one equation. So all these terms are known and you can find it from the literature. And the second one you can get from here. If you just P divided by Vt, okay. All these terms are material property, okay, because W, curve width, rho, these things. So P by Vt is known as your severance energy. So maybe if you are looking some papers or research, then it says that okay, this particular phenomenon depends on the material properties, because here there is nothing that is dependent on other factors. So we define sometimes that what is the minimum energy that is required for achieving a certain cut quality. Okay, if we cut it using Ms plus O2, we need lower severance energy than that. So this is just to give an idea, and you can have a rough estimate of the initial parameter window if you want to start the process. Of course, you can optimize, fine tune. So that covers the basics of the laser cutting. So I'll just finish after a few slides with some recent advances that not recent, these are also relatively old. It's called, so first one we have already discussed, this conventional laser cutting with gas assist. Second one is also oxygen assisted that we have already discussed. There is a variant, it's called laser cutting. If the full form is laser assisted oxygen cutting. Okay. So far, whatever we have seen is laser is used to melt the material, and then some gas is there, and then that is just removing the material. But in this particular process, the actual cutting is being performed by pressurized oxygen gas. Okay. Laser is facilitating the cutting process. So that is the reason what we ensure is we have relatively bigger size laser spot diameter. How do we do that? As we mentioned that we can have a plano-convex lens. We just move the lens in the upward direction. So obviously converge and then diverge, and depending on that you can select the right plane and you can ensure that the required spot diameter is ensured. So once we have a bigger spot diameter, inside that we have a smaller footprint of high pressure oxygen gas. So laser is preheating the substrate, and you are using oxygen as a cutting. So By this particular process, you can actually, it has been demonstrated up to 75 mm, which is quite high. 75 mm is, almost, this is 25, so almost like this much thick material you can cut. So it is actually competing with the plasma cutting, but plasma cutting is relatively costly. But why this particular process exists? Because this can actually give you a good, cutting thickness. So you do not need to go for high cost plasma cutting. So there can be an alternative. So this was done in India, or with a 60 mm thick plate in RR cutting road. So this has been already demonstrated back in 1990, and this is the actual figure. So this is a 60 mm plate, the cross section of the card, and you can see that there is a the cut quality is relatively good. It's not that bad, but there are some marks which you can optimize further. So 60 mm MS plate, 25 mm MS plate, and all these were done using home-built laser system. It was not imported or anything. It was done in India, developed in India, and everything was done in India. And of course, there was a variant where you can also design the supersonic jet, like Mach 1.8 means. By means of changing the design, you can ensure that the gas jet that is coming out from the nozzle is 1.8 times of the sound velocity. So sound velocity is 330 meters per second. So Mach 1.8 means 1.8 times the sound velocity at the room temperature.
Sir,
Yeah, please.
for this Mach 1.8, so what is the latest currently in the times now?
It depends on the material property, the material that you are using for, this is related to the pressure. So the material that you are using to make that particular nozzle, because every material has a fracture toughness, right? So what I know is, because this is also used for cold spray application. Cold spray deposition, where you use or deposit the material in supersonic velocity without melting. So up to 3.
3 plus 1.
Yeah, 3 or 4. Because beyond that, if you increase the max speed too high, the flow becomes turbulent.
Yeah.
So that is something is not acceptable.
No, that 3 is very high, sir.
3 is very high. So normally 2, 1, 3 is maximum, because beyond that it cannot go on like 100 or so, because that is not sustainable. It will form some kind of shock waves. So that creates problem.
Okay, thank you, sir.
Yeah, this is again the challenges that are normally there if you want to cut the mild steel with oxygen. It creates a lot of striation. Why I included this particular slide is there is ongoing research going on to minimize this striation front, because how the oxygen front moves, how the solidification front moves, there is a correlation. So although laser cutting process exists for a very long time, but these are some of the areas people are still working and trying to improve on. Yeah, this is basically the view, like how the laser beam interacts, and then how the solidification front moves. Yeah, so last 2 slides. So in summary, if I discuss about the process capability of the laser cutting, it can cut almost any material, right from metals, non-metals like ceramic, glass, concrete. Even if you want to cut the stones, you can actually carry out, use the laser. It can also cut textiles, leather, and then perspex sheet. Anything, almost anything can be cut, okay, with high precision. Cutting thickness can be as high as 60 mm that we have already demonstrated, and there can be different alternatives. So depending on the application, you can select the right laser system. But predominantly is the fiber laser that is being used at this moment, and the CO2 laser. And depending on the complexity, if you need to cut only a straight line, you just use a small CNC machine. But if your requirement is something like to make some kind of controls, so you can have either robotic system, or you can have a robust guarantee type CNC with lot of automation. If you want to have further monitoring capability, then you can have thermal cameras and other things. So, but that will add to the cost. So it depends on what is the actual application. This P by Vt terms, that is the CBS energy, will give you a fair idea that what is the material removal rate for a given laser power. Practical application can, now not only for laser cutting, nowadays almost in all the manufacturing, especially with the the 3D printing or additive manufacturing, now we find the applications of lasers almost in everywhere. And especially in India also nowadays, people are just catching up. If you want to mark or if you want to label something, that is also being done using laser, or if you want to make some kind of prototype, if you want to clean the surface, if you want to cut the surface, if you want to modify the surface, everywhere laser is having its application. So automobile or say textile, leather, furniture, shipbuilding, nuclear, almost all the cases we have this kind of applications. But cutting of diamonds is one of the popular applications of lasers, especially in India. And this is the advantages, like low curve width, high accuracy, low heat affected zone, very high productivity, and you do not need any sound barrier chamber for that. It's very easy to cut the hard materials. Since no physical tooling is involved, so there is no wear and tear of the tool. You just need to maintain the laser, the lanes, and you need to have a clean environment that is good enough to have good productivity. You can integrate with a CNC and software. You can cut the complex profile. You do not need any subsequent post processing for most of the cases, because you get sharp edges of the 90 degree. Very low distortion, because this something will not affect the surrounding region, so just cut it, and depending on the mode of operation that you select, you can actually vaporize the material without even touching the piece. You can also have 3-dimensional cutting. So if you want to have some kind of grooves, so you can have a scanner-based system and then you can do the cutting operation. Major limitation, although I should not say limitation, it depends on the application, but definitely laser is relatively costly than the normal machine tools. Cutting of highly reflective materials, again, it depends on the wavelength. For example, if I am using fiber laser and if I want to cut, say, pure copper, then it may not be a good idea to use the fiber laser, because the copper is having a very low absorptivity in the 1064 nanometer range. But instead of 1064 nanometer range, if I select a 532 nanometer laser, then definitely the same cutting operation can be done with ease. But 1064 may not be suitable. Cutting thickness more than 25 mm needs specialized nozzle, because up to 25 mm, for most of our research purpose, 2 mm, 1 mm is the range that we work. But for industry, it may be required. For that, you can have different configurations, like different nozzle tubes. This is just to give you an idea, these are the popular cutting methods that are available, and if I compare laser with that, so we have plasma arc, punch press, oxygen assisted cutting, O2 flame, wire ADM, water jet. So accuracy wise, it is moderate or in the good quality, and tool wear and change is almost negligible because it's a non-contact method. Ability to cut materials, because if you are using wire ADM, then definitely it only cuts the conductive material, because it is to complete the surface. But if it is a non-contact material, a non-contact way of removing the material, you can have better advantage. So the only thing is the capital investment. So that is the initial investment. So with that, I'd like to finish my talk. Yeah, if you have any doubt, query, you can ask. Yeah, I took a long time. Yeah. Or how many of, or any one of you are using lasers for cutting application at this moment?
For the last 3 months only we got 2 machines, sir.
Okay.
Laser cutting.
Okay.
We need to install and we need to start training also now.
Okay. So it's a fiber laser?
No, CO2 laser.
CO2. So it's a
laser is for both purpose, cutting and engraving.
Yes. So mainly you'll be targeting the perspex or non-contact. Non-metal. Maybe you will get some idea at least.
Definitely.
So that is something that is going on, but honestly speaking, this is the fundamentals of laser cutting. But if you see the actual technology, then we now have many things, because I didn't know that what will be the audience background of the laser cutting. That's the reason I didn't cover the advanced things. So you can actually play with the beam shapes. Nowadays we have advanced laser system. What we discussed is we are only using a spot diameter which is having a particular shape, right? Say a circular kind of shape. But it has been observed that if you change the beam shape, then you can actually have different cut quality, and that is the reason there is a new variant of the laser beam, laser source came up, where you can change the laser beam on the fly. That means if I am cutting in a straight line, at the beginning it may be circular in shape, but at the end or in between it can have some kind of geometry like a donut kind of shape. So it has been observed that if you have different beam shapes, then the cut quality will be different. So that is one variant that is coming up. And also we are predominantly so far we have IR laser, but now there are blue laser, which have better absorptivity. Again, that is the reason the first thing that I share is the fundamental is how the wavelength and the absorptivity varies. So people are targeting certain wavelength where we have better absorptivity. It's just to minimize or it's just to increase the productivity. So people are working on beam shapes, on wavelength, on different artificial intelligence and machine learning to optimize the thing, on process monitoring, so that you have better cut quality. Sterilization is one of the problems. People are trying with different materials, different process control, so that we have lower post processing time.
So great thanks to Dr. Sarkar sir from IIT Mechanical Engineering Department, IIT Delhi. I think our audience must have benefited a lot, especially those undergoing research areas. The way sir started on the very fundamentals of the laser, the processing, the various types, the way sir related and linked the mathematical equations with the practical applications. I really enjoyed a lot. Sir also told regarding the nozzle speed, we went up to 1.8 max, and in the body it has gone up to 3 max. The speed of a top supersonic is really great and interesting to know, which I was not knowing till now. I am very thankful to sir, the knowledge he shared with us, and hope sir will also entertain you sir in future also. Sure. So I thank you all. Thanks.
So we will have a group photograph now. Please come here.